Hi everyone, welcome back to my channel. In today's video, I will try to explain or show you the classification matrix or binary classification matrix. Let me just add these questions. Have you ever wondered how your email providers know which emails are spams? Sometimes you find in your spam folder some emails that are spam. Or how the doctor use AI to detect the disease like a cancer, or maybe a bank, how banks identify fraud transaction in real time. So these are the example of binary classification, let's say, problems where a model predict one of the two outcomes: spam, let's say spam or not spam, cancer or not cancer, and fraud or not fraud. So this, let's say, how do we know if this model is doing a good job? So after you training your model, so now let's say you move to the prediction before the production. So how do you know that if your model is doing perfect? So what if, let me just add this question, what if your email providers mark an important emails as spam? Or maybe what if a cancer detection model miss a tumor? So for instance, you put the image with the humor, let's say a disease, and the system said no, it's everything is fine, no disease. This is a big problem. And what if the fraud detection system flag, let's say a legitimate transaction? If you sometimes, let's say, some hackers are doing some online transactions, and the bank system said no, this is perfect, this is okay, while it's not. So here's the problem. So these mistakes can have a serious consequences. That's why we need, let's see, evaluation metrics to measure how well our models are performing. So today we are diving into the most important, let's say, matrices: precision, recall, F1, and the confusion matrix. Sorry. By the end of this video, you will not only understand these matrices, but you also know how to use them and when to use them to build a better model. So let's get started. So as you can see here in this image here, the during the training, let's assume this we are using linear regression or maybe support vector machine. It's just splitting the classes into different classes. I mean, the classes categorized into different classes: spam or not spam. Let's see. And during that prediction, you will use this model to predict, let's see, these messages here, and you will see here's the three okay and two spams. So this is the, let's say, the concept of how to evaluate your model, if your model is doing well or not. So let's say I will start with the confusion matrix. But before going to the confusion matrix, let's assume that our spam is the positive class and the ham is the negative class. Why it's false here? Sorry for the mistake. Okay, and please keep in mind, if you have the precision and recall or maybe F1 score, it's only and only for positive class. So F1 and recall precision rock only focuses on the positive class and doesn't know, or let's say show how your model does on the negative class. So this is, please keep in your mind. So for instance, in this video, I'm assuming the spam is the positive class, and now I will calculate the precision and recall based on this assumption. And if you assume, if you change the positive class to, let's say, ham, so in this case you will have a different calculation. So just please keep in mind, maybe this could be a interview question. And let's see, this is the confusion matrix. With this assumption, spam is a positive class. So here you have positive and true positive. It means the model correctly predict spam. So the true positive The table, let's say the data I have, the email I have, it's spam, and true positive, it's classified as spam. And let's see false positive. Let's see false positive. False positive, the model incorrectly predicts spam. So for instance, the email is not spam, it's ham, but the model classified it as spam. And in a false negative, the email itself, the actual email is negative, it's a spam, but it's classified as ham. And for the true negative, the email is ham and also classified as ham. So the confusion matrix, let's say the accuracy, it's just summation of this divided by the whole summation. Let's see the, sorry. Let's have a look in the equations. As you can see here, accuracy is true positive plus true negative divided by all values: true positive, false positive, false negative, and true negative, as you can see here. And here the precision and recall and F1. So the precision, as you, this is after assumption. Our assumption as spam is the positive class. So you can see true positive. Now, if we change the positive class to ham, we'll have, as I said, different calculation. So the precision is measure the accuracy of the positive prediction. So and also it's answer all of the emails predicted as spam. How many actually are spam? So let's say, sorry, this is the spam file, spam classified, and here we have the spam true positive plus false positive, the ham emails that are classified as spam. And the goal of this, or when to use this, if the false positive, it costs high, let's see. So for instance, let's assume that one email is actually it's spam. No, sorry. Let's see the email, the one email is ham, and by the model is classified as spam, and it will be, let's see, moved to another folder, and it might be ignored or maybe deleted, while maybe it's important. So for this, we need to use a precision if we need to, let's say, reduce the false positive. And for the recall, it's called also sensitivity. It's measure the ability of the model to identify all positive instances, and it answer all the actual spam emails. How many did the model correctly identify? So in this recall, we try to reduce the false negative. What is the false negative again? The false negative, it's, let's say I have a spam email, and this spam email is classified by the model as ham, and it's moved to the, let's say, to the inbox. And when you click, let's see, or open this email, you will have some attack, I don't know. So it depends now when you decide to use precision and recall. And the F1 score, or it's called harmonic mean. You can see harmonic mean. It's a mean of a precision and recall. It's a balance between both uh, metrics, and it's used, let's say, for a class distribution is unbalanced. So what does the unbalance means? Unbalance assume that you have a data set and you have, let's say, two classes, but the one class, positive or negative, is high. Let's say it's for the spam file, for the spam emails, you have 1000, and for the ham emails you have 10 or maybe 100. This is called unbalanced data set, and there's of course a solution how to solve this imbalanced data. So we will cover this in the next videos. And let's just give you an example here. So assume this is the actual label. I have my training, let's say my testing data set. I have the actual label This is the email one, two, three, four, five, till I don't know 20 or so. The first email is spam, and our model is predicted as a spam. So it means now true positive, right? So I will put here one. Now the next email, its actual email is spam, but the prediction is spam. I mean, not but it means correctly classified. So I will see here one. So now our email or the email is ham. Oh, sorry, our email is ham, but it's classified as spam. So in this case, what we should do? False. It will be false positive. It means the email was false. I mean, not including to the it's including to the false class, but it's classified as a positive, right? So now we have here to increase the to put the one in the false positive. And let's see, spam. Yeah, spam. This one email here, it's called class. I mean, this is the actual email and classified as ham. So in this case, we have true, not true negative. It's a false negative. So this it's the email is let's say as it should be positive, but it's classified as ham, and that's why we should see it false negative. It means it was true, but it's assigned to true to false. And here you see accuracy is calculated, just sum up all of these true positive and true negative and false positive and false negative. And you can see accuracy it's point 0.6, point 0.6, let's say point 0.60 or 60%. And the precision and recall is 26, I mean 62 and 67%. And the F score or harmonic mean is 0.6, 64. So now when let's see to use this, so I will recommend you to use only one and at most let's see two matrices. Don't use all of this. So if you have a system, try to let's see stuck with one that will generalize your performance. So for instance, accuracy, I will see accuracy, it's not a solution for all of these cases, as we have seen in the unbalanced data set. I think we have it here. So let's say this is the positive and we have the email. Well, so assume that we have 900 of spam and 100 of ham emails. So the classifier predict all the emails are as spam, and you can see we have a good accuracy, right? But the 100 spam is classified as I mean the 100 emails of the ham is classified as spam. But in this case, we have a good accuracy. But this is in case of unbalanced data set. So don't use accuracy on the unbalanced data set. So, and the question is now, when to use precision recall or F1? As I said, precision is important when the cost of the false positive is high. And in this case, for instance, you have a ham email, right? And our system, let's say we need a ham, it has to be classified as ham. It's not supposed to be moved into a spam folder. So in this case, I will use precision. But in case I need to reduce, let's say, the false negative, to reduce the false negative, I will try to use the recall. So the false negative, it means sometimes the spam folder, the spam emails is classified as a ham. And in this case, it might be a huge problem, let's say a big problem, because the spam folder, the spam email will be moved into your inbox. And when you open this, it might be attack or hack to your system. So it depends on this. Let's see, let's give you an example. For instance, MRI images classifier. So sometimes, let's say, assume you have a system that predict the images as a tumor or not, positive or not positive, or negative. So if so, let's say just assume this. The images that we have is has a tumor. Okay. Now the system is classified as non-tumor. It's normal. So in this case, it's a big problem because the person here will be treated as okay, and after a while, he might be died. He might be die. And let's say go to the another example, the opposite case. If the images of the patient are, let's say, okay images. I mean, no images, no tumor, but the system is classified as a tumor. So in this case, it will be as a tumor, right? But it will be a shock for the patient maybe, but they will try to add to make another test to let's say be quite sure. I mean manual test, right? And in this case, it's false positive. It might be okay, but false negative. It's a dangerous. And let me just move to the Python code as I promise for every lesson. So you can see here, you can use Sky learn matrices, classification report, and confusion matrix. So assume this is our labels. So we have these labels, and we have the prediction is our model. Let's see, predicted these values here. In the next lesson, I will try to show you this real example of the spam and ham classifier, but only to give you a overview how to evaluate your system, how to see my system is working good. And this is a confusion matrix. It's a defined function here. You just input the true positive, the actual labels plus, I mean not plus, and the predicted ones. And you have the report as you can see here, not spam, precision, and recall. As you can see here, precision, recall, F1 and support is calculated two times. One for the one for the ham and one for spam. As I have said in the beginning. So we assume that the spam is positive and the ham is negative. And the program, or let's say the library, is calculating in both directions, not only one. So yeah, I think now it's I have finished this, and as you can see, it has take much time for me to prepare this. So please, if you like this, please subscribe, like the video, and of course, if you have any question, drop it in the comment below. I will answer. Thanks for watching, and see you next time.